everyone, it's Mrs. Schmidt here today, and we're going to talk about finding, organizing, and using equivalent ratios. Yesterday, you explored what ratios are and how you see them in real life. Today, we're going to talk about how ratios can actually have equivalent ratios, ratios that make the same comparison. So, let's get into it. Equivalent ratios, as I was saying, are two ratios that describe the same relationship. Let's look at an example. Here in the picture, you can see that the ratio of stars to hearts is 2 stars for every 1 heart. As you recall from yesterday, you can also express ratios in fraction form. So I will display that here. 2 stars for every 1 heart. Our picture shows us that 2 stars for every heart is equivalent to 4 stars for every 2 hearts, which is also equivalent to 6 stars for every 3 hearts. Let's go back and see how we can see this in our pictures. 2 stars for every 1 heart. Over here, I can make a group of 2 stars for every 1 heart as well. And over here you can see it's the same. 2 stars for every 1 heart. So equivalent ratios are ratios that are all making the same comparison. They can all be simplified to lowest terms to make the same comparison. There's a lot of similarities between equivalent ratios and equivalent fractions. So let's take a look down here. How do you get 2 to turn into 4? Well, you would multiply by 2. And keeping with the same thing on top and bottom, multiplying by 2, that checks out. It works. Now, as you can see, 4 to 2 is not as easy to get to 6 to 3. So what we can do is you can do 2 to 6, times it by 3, and multiply the bottom by 3, and it works. And since 4 to 2 is also equivalent to 2 to 1, even though it wasn't easy to make the 4 turn into a 6, you could have if you were using a decimal number. Let's continue on. A ratio table is a tool used to find and organize equivalent ratios. So here you can see we have a ratio table of pens compared to pencils. And they started us off with the smallest ratio being 1 pen for every 3 pencils. These 2 examples are more of a simple ratio table because we can use repeated addition of the original ratio to figure out the entire table. So if you see, if I have 1 pen for every 3 pencils, and then I all of a sudden have 2 pens. So the reason we said repeated addition is because it's of the original ratio. So how did I get 1 to 2? I added 1. Okay, well, if I add 1, that changes my ratio. I need to repeatedly add the same ratio. So plus 1 on top and plus 3 on the bottom. So that would be 6. If I have 9, how do I do that? Well, I'm going to add another group of 3 pens and another 1 pencil. So I would have 3 pencils. Over on another example for dogs to cats, we're going to repeatedly add. So I have add a 6 and add a 4. So that would give me 8. Now, wait a second. The rule doesn't work on our last column. If I add another 4, does it get me to 24? It doesn't. Well, I have a couple options. I could go off to the side and continually repeatedly add my original ratio until I get to 24, or I could use some concepts that we learned with equivalent fractions. And what I could do is say, can I turn 4 or 8 to create a 24? How can I do that? Well, the good news is both of them can turn into 24. So let's start with the 8. I'll just choose the 8. What do I do to an 8 to turn it to 24? I'm going to multiply by 3. Let's do the same thing over here. Multiply by 3. 12 times 3 is 36. So we just discovered something here. We discovered that there are simple versions of ratio tables that it keeps the same pattern of repeatedly adding the original ratio. But once in a while, you may start repeatedly adding that original ratio, but then you get to something that it takes a lot of effort to continually, repeatedly add up to that ratio. So we're going to use knowledge that we've learned from prior concepts, and we are going to multiply by a quantity of 1, same thing on top and bottom, to keep that ratio equivalent, and we can create the new ratio in a more efficient manner. On that note, understanding that concept makes it a lot easier when you get to more complex ratio tables. So more complex ratio tables, you can't just repeatedly add the original ratio. You have to use what you know to find the missing pieces. So you're going to have to do a lot of detective work. So let's try some examples. Okay, I see that the ratio that I was given was a 2 to 6. Well, can I get 6 to equal 3? I can. How do I do that? Am I going to use multiplication or division? I'm going to divide top and bottom by 2. And when you do that, 2 divided by 2 is 1. So I figured out my ratio in simplest form, and that's going to be really helpful to help me figure out the rest of my ratio table. Let's continue. Can 6 turn into a 9? Not very easily. So I could do 3 times 3. Over here, do the same thing to top and bottom. 1 times 3 is 3. Can I get 9 to turn into 18? I can. Just multiply by 2. And you're going to get 6. So what this says, this table is holding a whole group of equivalent ratios. And all those equivalent ratios you can push off to the side and say 1 to 3 is equivalent to 2 to 6, which is equivalent to 3 to 9, which is equivalent to 6 to 18. All right, let's come over to another example. So I see 18 and 72. Well, can I make 18 turn into 15 easily? Nah, not really. Can I make 18 turn into 10 easily? Not really. Oh, this is turning out to be kind of difficult. So I know I can create an equivalent ratio by reducing. So I might come off to the side and say, well, let's reduce this ratio to lowest terms. You can start by saying, okay, I see that they're both divisible by 9. So if you're going to divide top and bottom by 9, 18 divided by 9 is 2. 72 divided by 9 is 8. And I can actually go one more time. I can divide top and bottom by 2 over 2 and get 1/4. So I just created a couple equivalent ratios right here. Both of them might be helpful to help me over here. Sometimes when I get the ratio in lowest terms or simplest form, I like to write it in front. You can literally use this ratio to figure out the entire table now if you wanted to. What do you do to get to 10? You're going to times by 10. So what is 4 times 10? 40. Oh, this one became a lot more easy now. I've got 40 to 80. I'm just going to times by 2. So let's do the same thing up here. Times by 2. 10 times 2 is 20. All right, now I need to get to 15. So none of my choices on my top row are as easy as just using my simplest form ratio. So I'm going to times 1 by 15. Come down here, I need to do the same thing on the bottom. Times 15. 15, 30, 45, 60. All right, and I'm done. So you've got some options. You can always take a ratio that's complete that you know, simplify it to lowest terms, and then figure out your table. Or you can just, as you figure out ratios, use them as you figure them out to figure out the rest of the table. All right, everybody. Go practice your ratio tables, and I hope this was helpful. Have a great day.